Hey everybody, this is Larry. This is day 23 of the February LeetCode Daily Challenge. Hit the like button, the subscribe button, join me in Discord. Let me know what you think. Today's problem is congraph. So you're given an undirected graph. Return a deep copy of the congraph, okay? So you just literally do the same thing. What is the node? Node is, okay. The node is just any node. Okay. How do I want to think about this? I guess just depth first search, right? Or recursion, maybe that's the better way. Maybe I would have something like, this is going to be implementation heavy, so I don't think there's that much theory per se. Other than making sure you don't process each node more than once, but we can do something like process, or maybe a better way is just breakfast, like a queue-based solution, because since I am essentially using that language of processing, which so maybe this is more intuitive, right? So something like this, or why is unique, okay? So this is just so that it makes it easier to have a unique identifier. That's why they do it that way. But if it isn't, then it's a little bit annoying, but you still can do it because you're doing by pointers anyway. So yeah, so then maybe I'll have a scene as you go to set. All right. So yeah, so then scene add node.wow, and you can maybe just add an enqueue just to make this slightly easier for me. So then you just do this, right? And then now we want to enqueue node. I'm just gonna call this root. I know this is not a tree. I'm gonna call it root just so that it's slightly less confusing, and shadowing of variables and stuff like that. Where it's consistent, but it's just like easy to mess up, especially once you do more complicated things, right? Yeah. Oh yeah, I forgot to mention I'm still in Cartagena. Did a couple walking tours today, so that was kind of fun. I'm still tired though, but hopefully you can see from my voice that it's like I'm feeling a little bit better. So maybe just because I had a cough drop recently, so I don't know. But yeah, so you include this. So now, wow, length of, and this is just regular professor stuff. Current is you go to queue.pop left, right? And then now we process. How do we look it up, right? Okay, let's just say, I don't know. There are probably better ways to do it, but I'm just gonna have a thing that just called dupe. Is you go to lookup table, right? And then, excuse me. Okay. This is way yucky. I don't recommend it. But I am a little bit lazy today and tired and still a little bit coffee. So I'm just going to do this, and then so that we can return this later. And then for the other nodes, for processing, we just go dupe dot. Maybe I don't need scene in that case, but dupe dot. So then when we process this node, what we want to do is create a new node. This is a little bit awkward actually. Yeah. Okay, so then I'll just have a constructor as well, so that is a little bit easier for us. Or get a getter maybe. I just call it getter because I think get may not be a keyword, but I don't know. So then this allows us to use dupe by something like dupe of node.row is equal to a new node with just node.value. So this creates a new node, a new copy of the node, and without the neighbors. So that's basically the idea. And then here, now we can do current dupe maybe. Let's go to getter of current, right? And then now we want to process the neighbors. Well, first we want to set the neighbors in general. So for x in current.neighbors, that's a terrible way of a name, especially since it's easy to just call it neighbor. So for neighbor, first we want to construct the nodes first, right? but we can also do current dupe dot neighbors dot append getter of neighbor, right? I think that will give us so this gets us the duplicate version of the node, and this just adds the edges, so then we're good there. Oh, actually this is wrong, huh? So what I meant to do this, but if node is not in dupe, then we do this thing, and then also we don't return anyway, so maybe that would have been okay. But yeah, so something like that. And you could actually technically, I guess technically you don't need cache. You could just write like a memorization type thing, but we'll skip that for now. Essentially we're doing memorization. But yeah, so now we do a current dupe. We append it to the getter, so this looks good. And we also want to do, we want to do another loop. Maybe we could have kept in the same loop. I don't think it matters that much, but I just want to separate them out so it's slightly easier to read, at least in this particular case. And also if I'm doing this on production, maybe I separate out to another function. Don't know how I feel about that. But yeah, so then now we just do something like enqueue of neighbor. And maybe I'll change this to maybe enqueue neighbor. And what I mean to here is that I would do something like if node.route is not in scene, we do this so that we don't do duplicate times. And I think that's most of what I want to do. Maybe maybe I forget something, but that's most of the ideas I have in my head. Let's see if that works. Invalid syntax. What am I writing? I'm trying to write English in here. That's odd. Weird, Larry. Okay. No, what was that? Oh, what did I do? Oh, whoops. I meant this, so that's fine. I mean, well, it's not fine, but it is an easy fix. Actually, we could have just gotten getter of group anyway, so maybe that would have been slightly better. Now that I cleaned up what I wanted to do, one of the things I would say is that, as you can see, you know, sometimes cleaner code does require a couple of iterations, maybe mentally or not. So definitely don't feel ashamed about that. But you know, just keep doing you. Oh, none type is do we just have a none? This is the none is kind of weird, to be honest. But 0, okay, fine. I mean, okay, fine. It's good that they give us that example, though. I would have been a little bit sad, but yeah, it looks good. Let's give it some submit. Hopefully it's good. Okay, cool. 694-day streak. This is going to be, this is essentially a queue-based breadth first search, so type thing. So this, and every node gets processed once. So and of course there is a for loop in edges. So this is going to be O of v plus e time and space, and of course if you know and that's of course linear because that's the size of the input. Technically e can be v squared, obviously, but that is the size of the input, so it's linear, right? Also it's only within 100, so it should be good either way, but obviously you need to do the complex analysis. But yeah, all right, that's all I have for this one. Yeah, I mean, I'm still thinking that well, so I'm gonna call it a quick out. I'll see y'all in a little bit. Stay good, stay healthy, take good mental health, and take care. Bye bye.